morning, guys. I am Fitzgerald Erlongakit from BS Ed Math 2A. And for today's video, we will going to make the final project of our linear programming, which is the transportation problem. So here is our problem. Our mission is to reduce the total cost of the delivery from each supplier. So by getting the total cost, we will going to use the three methods. The first method is the northwest corner method. The second is the LCM, or the least cost method. And the third is the VAM, or the Vogel's approximation method. And then after that, we will going to identify which total cost is the least and use this to our MODI, or the modified distribution. We use the MODI to get the cost delivery of the used and unused routes. So we must evaluate the unused routes to identify if there is a negative value. So if there is a negative value, we will going to loop. So the purpose of the looping is to reduce the total cost. So without further ado, let's get right into it. So in this method, we will going to start first at the first value. So we will going to satisfy the demand, which is 80, and satisfy the supply, which is 75. So since it is 75 here, so we will put 75 here to satisfy the supply. So 75. So we will crush this out since it is satisfied, 0. Next, so in the bottom, which is 8, so since 75 minus 80 minus 75 is 5, so the remaining is 5 to the demand, so we will put 5 here to satisfy the demand, which is 80. So the demand now is 0. Next, since this upper portion is satisfied, so we will let this as imaginary. So next is we will move to 7. So since we have 5 here, so we will going to crush this out and become 120. And since the demand is 65, so we will put 65 here to satisfy the demand. So the demand now is satisfied. So 120 minus 65 will become 55. So since these two are satisfied, so we let this as imaginaries, then move to 9. So since our supply left is 55, we will put 55 here to satisfy the supply. So our supply now is 0. So this corner, or this portion, and these portions are satisfied. So one left is 70 and 85 and 100. So next, since we have 55 here, so we will subtract it to 70. So all we have left is 15. Yan, 15. We will put 15 here to satisfy the demand, and subtract 15 here, so 85. So to satisfy this and this, we will put 85 here. So 85 satisfy the demand and the supply. So that's it, the west corner method. So it is simple. Next step is to identify the total cost. So total cost so we will use these values and multiply them. 10 times the value 75, then add to 8 times 5 plus 7 times 65 plus 9 times 55 plus 10 times 15 plus 12 times 85. So 10 times 75 is equal to 750 plus 8 times 5, 40 plus 7 times 65 is equal to 455 plus 9 times 55 is 495 plus 10 times 15 is 150 plus 12 times 85 is 1020. So add them all, the result is the total cost is 2,910. The next method is the LCM. So for this method, we will identify which is the least of the column to start first the reduction. So in this row, the 4 is the least, so we will going to start at 4. So we will put 80 on 4 to satisfy the demand. So we will cross this out to 0. So this row is satisfied. So next, in the second column, the least value is 7. So we will put 65 here to satisfy the demand. So the demand now is 0. And when we add in these columns, we will subtract it here. So 80 minus 100 is 20. 65 minus 25 is 60. So next, here the least value is 9. So we will put 60 here since the supply left is 60. So our supply now is satisfied and our demand now is only 10. So next is here. We will put 10 here to satisfy our demand and subtract it to the supply, which is 10. So next, we will find the least in this column or row. So since this current row is already satisfied, so we will move to the next least value, which is 12. So we will put 10 here since the remaining supply is 10, so 0, and subtract it here 75, and the last value is 20. So we will put 75 here to satisfy our demand and our supply. So we will cross this out and become 0 since they are both satisfied. The next step is also to get the total cost. So total cost. So same as before. So 40 times 80. I mean 4 times 80 plus 7 times 65 plus 9 times 60 plus 10 times 10 plus 12 times 10 plus 20 times 75. So 4 times 80 is equal to 320 plus 7 times 65 is 455 plus 9 times 60 is 540 plus 10 times 10 is 100 plus 12 times 10 is 120 plus 20 times 75 is 1,500. So the total cost is 3,035. So that's it, the least cost method. The next method is what we call VAM or Vogel's approximation method. So in this method, we will find the two least elements on each row, then subtract them. So in this row, the least element is 4 and 8. So we will going to subtract them. So 4 minus 8 is equal to 4. So we will put here, so 4. Next column or row, the least element is 7 and 8. So 8 minus 7 is 1. 9 and 10 is equal to 1. 12 and 11 is equal to 1. In here, in the column, the least element are 10 and 13. So 13 minus 10 is equal to 3. Here, this column, the least element is 8 and 7. So 8 minus 7 is 1. And then in this column, the 8 and 4, so it's equal to 4. So what we will do here, we will find the greatest penalty in the row or a column penalty. So since there are two 4, so the highest penalty is 4 and there are 2, so we will have to choose one. So I choose this, so we're going to encircle it. So since we chose this, so we will going to start at the least element in this row. So we will put 80 to satisfy our demand and subtract it to the supply. So we will make the same process. So since it is already done, we put X here and let this row as imaginary. So yan. Tapos same process, 8 minus 7 is equal to 1, 10 minus 9 1, 12 minus 11 1, and since it is satisfied, so our next least element are 17 and 13. So 17 minus 13 is 4. So 7 minus 9 is 2. 8 minus 10 is 2. So we will find now the greatest penalty. So since this is the greatest penalty, which is 4, so we will encircle it, and move on this column. So since 13 is the least value in this column, so we will start here. So to satisfy the supply and the demand, we put 65 here. 65. So the demand are now satisfied, and the remaining supply now is 10. And since our demand now is satisfied, so we put X here. So these two rows are now satisfied, so we'll let them as imaginaries. So the left now are the L3 and the L4. So repeats same process. 10 minus 9, 1, 1, then so the remaining values are 17 and 20. So subtract them. 3, 2, and 2. So the greatest value is 3. So we encircle it and start at the least. So since our supply now is 10, so we put 10 on 17 to satisfy our supply, and subtract 10 here. So since the supply now is satisfied, so we put X here, and let this as imaginary. So the remaining values are 9 and 7, I mean 9 and 11. So subtract them, so equal to 2. 10 minus 12 minus 10, 12 minus 10 is 2, and then (9 minus 10, 1, 12 minus 11, 1. So since there are two greatest elements, so we will choose one. So we choose this and start at the least element, which is 9. So since our demand is 60, so we will satisfy it by putting 60 in 9. So our demand now is satisfied, so we put X here. Since this row are satisfied, then repeat same process. 1, and then 11, and then 12. So why 11 and 12? Because we cannot subtract any more values, since 11 and 12 are the only values left. So the greatest value is 12, so we will start at 12. And since the remaining value of our supply is 20, so we will put 20 here, satisfy our supply, subtract it here, and become 65. Oh, we forgot something. So 65. So we put X here, since our supply is now satisfied. So repeat same process. So 11 X and 11. So since 11 are the only remaining value, so yan. So our supply and demand are 65, so we going to put 65 here to satisfy our supply and our demand. So done. We get all the row and column penalty. So since we satisfy the supply and the demand, we will now get the total cost to identify which method has possessed the least cost element. The least cost. So total cost so 4 times 80 plus 13 times 65 plus 17 times 10 plus 9 times 60 plus 11 times 65 plus 12 times 20. So 4 times 80 is equal to 320 plus 13 times 65 is 845 plus 7 times 10, 17 times 10 is equal to 170 plus 9 times 60 is equal to 540 plus 11 times 65 is 715 plus 12 times 20 is 240. So the total cost of our VAM is 2,830. So in comparison, so the least total cost is the VAM method or the Vogel's approximation method. So here. Since the least total cost that we get came from the VAM, so we will use its values here. So and evaluate the cost delivery for the used and unused roads. So evaluating the used roads. So our U and V are the cost delivery. So let U1 is equal to 0. So first we will use the used roads. So since J1 and L2, so 13. So U1 plus, so this is U1 and this is V1. So U1 plus V2. U1 plus V2 is equal to 13. And to get our V2, so we will transpose it. So V2 is equal to 13, and since our value of U1 will at 0, so 13 minus 0 is equal to 13. So our V2 is 13. So next, J1 L3. J1 L3 17. So U1 plus V3 is equal to 17. To get V3, so 17 minus the value of the U1 is 0, so is equal to 17. So our V3 is 17. Next, J2 L3. U2 plus V3 is equal to 9. And since we don't have the value of U2 and the value of since we have now the value of V3, so we will get the U2. So U2 is equal to 9 minus 17 is equal to negative 8. So our U2 is negative 8. Next, J2 L4. J2 L4 11. So U3 plus V1 equal to 11. So since we don't have the value of U3 and V1, so we will move to the next value. So here, J3 L1 to U3 plus V1. So since we have now values of our U2, so we will get the V4 to 11 minus negative 8, so is equal to positive 19, since positive times negative is positive. So next is J3 L1. J3 L1. So U plus V is equal to 4. So since we have now since we don't have the value of our V1 and U3, so we will move to the next. So J3 L4, which is 12, U3 plus V4 equal to 12. So we will get U3 to 12 minus V4 is 19. So minus 19 equal to negative 7. Our U3 is negative 7. So since we have now our U3, so we will back here to get our element. So V1 equal to U3, which is negative 7 minus negative 7 equal to 11. So our L1 is 11. Next is we need to evaluate the unused roads. Is equal to 20 minus U is equal to 0 plus V4 is equal to 19. So the result is 1. Next is the L1, 2, so 8. So C1 2 minus U2 plus V1, 8. So U2 is negative 8 and V1 is 11. So is equal to 8 minus 3 is equal to 5. So next is L2, 7. So L2, 2 minus U2 plus V2 equal to 7 minus U2 is negative 8 and plus V2 is 13 equal to 8. I know. It's equal to 7 minus 5 is equal to 2. Next is L2, 3. C2 3 minus U3 plus V2 is equal to, or U3 is negative 7 plus V2 is 13. So equal to 8 minus 6. Last is L3, 10. P33 minus 10 And since we have a negative value of the unused rows, so we will going to loop. And since the negative value is on our L11 or the 10 here, so in our looping we will going to start here. So we will now find the list of these values that we added to each values. So the list is 10. So we will going to add 10 here on our 10, since this is the start, since it is negative. And then in the corner, so minus 10 here and 17, since it is a corner, and here plus 10 and 60. So we will going to add and subtract 10 in each corner. So plus 10 and 60, minus 10 on 65, plus 10 and 20, and minus 10 on 80. Next step is we will going to get the total cost of the looping, since we have now new values. So total cost, so 10 times 10, since we add 10 here, plus 13 times 65, plus, so 17 10 minus 10 is 0, so we will not include 17 anymore. So instead we move to 9. So 9 times 60 plus 10 is 70, plus 11 times 65 minus 10 is 55, plus 12 times 20 plus 10 is 30, plus 4 times 80 minus 10 is 70. So 10 times 10 is 100, plus 845, plus 9 times 70 is 630, plus 11 times 55 is 605, plus 12 times 30 is 360, plus 4 times 70 is 280, is equal to, our total cost now is 2,820. Compared to our total cost here, so our total cost now has reduced to 10. So next we will going to evaluate the used rows and unused rows. So we will now let U2 is equal to 0. So U1 plus V1 is equal to 10. So since we don't have the value of the U1 and our V1 here, so we will laktawan muna natin. So U2 plus equal to 9, and since we have the value of our U2 is equal to 0, so V3 is equal to 9 minus 0 and 9. So our V3 is now is equal to 9. And then So since we have value of our u2, so v4 is equal to 11 minus v1. So v4 now is 11. So u3 plus v1 to 4. u3 v1 4. So since we don't have value for u3, since we don't have the value of u3 and the v1, so we will back out. So u3 plus v4, u3 v4 12. So since we have the value of v4, so u3 equal to 12 minus 11, which is equal to, and our u3 is equal to 1. So back here, so v1 equal to 4 minus 1 equal to 3. So our v1 is equal to 3. Next, u1 plus v2 equal to u1 v2 13. So 13. So v2 equal to 13 minus, so minus 7 equal to 6. So we will go back here. So we have now value, so we will get our u1 equal to, our v1 is 10 minus here, our v1 3 equal to 7, our u1 is 7. Since we now identify our evaluation for the used routes, so then we will now identify the evaluation for the unused routes to determine if there are still negative values. So if there is still negative values, so then we will loop again to reduce the total cost of delivery. So let's evaluate the unused routes. So our u1, so u1 here, and v1, u1 v4 or u1 v4. So unused routes 20. So 20 minus, so 7 plus 3 is equal to 20 minus 10, or the u1 plus v1. So u2 plus v1, the 8 here, so minus 0 u2 plus v1, so is equal to 8 minus 3 is equal to 5. So u2 v2 or 7 minus u2 plus v2 6 is equal to 7 minus 6 is equal to 1. Next is u3 v2 is equal to 8 here, minus v3 u3 1 plus 6 v2, so is equal to 8 minus 7 is equal to 1. Lastly, the u3 v3 is equal to 10 here, u3 and v3 10 is equal to minus 1 plus 9 or U3 plus V3 is equal to 10 minus 10 is equal to 0. And since there are no negatives, therefore it is not possible to reduce the total cost. Result, X optimum. So we have 10, 0, 70, 65, 0, 0, 0, 70, 0, 0, 55, 30. So our cost or the delivery minimum, the S minimum is 2,820. So that's it. That's all for today's video. So we reduce the total cost to 2,820. So I hope you learned something. I hope you understand my tutorial. Thank you for watching, guys. Peace. I hope you learned something from my tutorial. I hope you understand. Thank you for watching.